Thank you all for joining us on this webinar. For those who don't know me, my name is Florian Karl. I'm the manager of the Yale Quantum Institute, and I'm the host of this series of non-technical talks, co-sponsored by the Franke program in the science and the humanities. The idea of this series was to talk about science, not in a scary way, but by mixing other topics like humanities, art, design, music, and try to really engage on these topics that are seen as difficult, but that we can really make accessible to everybody. So this is the 15th talk in this series, and we are delighted to have Klem Jankiewicz, who is a designer and uses her practice to design interface without no code for quantum computers. So it's very exciting to have her this morning or this afternoon, currently in Israel. So Klem Jankiewicz designed and builds this interface, but before this, she was working with museum, theater, and other educational institutions to create exhibition and interactive installation, including one on the façade of the Polin, one of the most famous museum in Poland. And recently she has moved a little bit on the field of quantum physics, working in collaboration with physicists and engineers. She has worked with the Center of Quantum Technology in Singapore, Xanadu in Canada, Pasqal in France, and currently with Classiq Technologies in Israel. And so the idea for her was to build all this interface, and of course she will talk about this in a few minutes. But she has developed, among other, some game and educational experience like Quantum Flytrap, Pulsar Studio, and Virtual Quantum Lab. And so we have a lot to talk about today. And so we are very excited to have you at YQI virtually, but hopefully at some point on site. Thank you so much for joining us.
Hi, thank you for having me, Florian. It's, I'm really happy to be here virtually. I'll talk today about mostly the project I did in the quantum industry and how I look at it and what's important for me there. My name is Klem, and I'm a designer. And for the last few years, Florian just mentioned, I've been working with the quantum industry, mainly building visual graphical user interfaces to interact with the quantum technologies. And this is what I'll be talking about today. And I'll start a bit about user interfaces in general and how I see this and what's important for me and why I think building those visual interfaces brings value. And then I'll show you a few examples of my works. So one will be Pulsar Studio we built for Pasqal. I'll show you Quantum Flytrap Lab, an interactive optical table, which is an educational tool, and also show you a sneak peek of something that we're working on with Classiq, which is not yet released. So it'll be only show a bit of it, only the design, but hopefully it'll be available quite soon. And also I'll show one non-quantum project, but also it's something that I think adds to this conversation about user interfaces. So user interface. What is a user interface? A space where interaction between humans and machines occur. It's a way we interact with the technology, right? So a language, different interfaces are. We can think about it as different languages have to interact and participate in the technology. And of course, there are many different interfaces, starting with what you see on your screen. That's like the most obvious one, but also, of course, like a mouse or keyboard. There are voice interfaces. There are interfaces based on code or more visual ones, like the ones I'm designing and building. And we need all those different kinds of interfaces because they answer to different types of users, different use cases, different situations. So, for example, a fully visual interface probably could be a bit problematic when the vision is impaired. So anything from blindness to looking at your phone in the full sun when you can't really see anything, right? So like different types of users, but also just different situation, different use case. So those different types of interfaces, then they answer to those different needs. And essentially, by choosing what type of interface we build for a specific technology and how we design this interface is a choice, is a decision of who can participate in the technology. And this is something that is very important for me, especially if we want it's not only quantum, any technology to be inclusive. I think it's something to really think about. And when we do talk about quantum computing, the most popular types of interfaces are very text-based. This is so it's usually either code, usually some kind of Python library, or of course the scientific text. And these are great interfaces. Maybe scientific texts aren't a typical kind of interface, but in this situation, I do see it as a kind of interface, because it is a way to understand the technology or to participate in the technology. So these are of course great, right? So this particular example is from Pasqal, because in a few slides I'll show an example of a project of a different interface we did for them. So these are really, really great, but they're not for everyone. So one obvious example would be, if I don't know Python, I cannot really use a Python interface. And the same with scientific texts. They require quite a substantial scientific knowledge to understand them. And when we talk about quantum computing, a technology that can potentially really at certain point can impact everyone's life, can change a number of industries, then I think there are a number of different use cases and user groups that these specific interfaces aren't necessarily enough. And one example will be a public debate that will be important or is already important, and we should have ways and tools for a more general public to be able to participate in this technology. Of course, education, this is, I think, quite obvious. We should lower the entry point. We should make it much easier for people to enter this domain, but also all sorts of business situation. And this is something that comes, that I hear a lot with while working with the quantum industry, that, this is a very, very complex technology. And sometimes there are certain situations where maybe those non-physicists or people who are working with those technologies, they would require some more intuitive way to participate or understand or interact with the technology. But I also think there are many ways that it can be valuable for research and even for the most advanced users. And I will also talk about it with the specific examples of the interfaces I did. So I think it's really, really important to try to think of different ways that we can produce different interfaces, different tools we can build for people to access this technology and to interact with this technology. And the specific type of interfaces that I build are the visual interfaces, the graphical user interfaces, or the no-code or low-code interfaces. This is what I'll show you now, a few examples of projects I have worked on. So the first example I'll show is interface we built for Pasqal. So Pasqal is a startup from Paris. It was co-founded by Alana Specht, the Nobel Prize winner from 2022. And we built for them this, it's like a visual and interactive representation of their technology, and it's a no-code development platform for neutral atom quantum computing. And I'll go back to this slide I just showed a minute ago. So these are the main ways to interact with their technology, to understand the technology. So they have Pulsar, a Python library, and of course, a lot of amazing research, a lot of scientific papers. And again, these are great, but they were looking for another way to showcase their technology and another way to, they were looking to build another way for the users to be able to interact with their technology. And this is when we built the Pulsar Studio, this no-code development platform, online platform for Pasqal. And I see those three interfaces as just like different languages we can use to interact with the same technology, three different representation of the same technology. And they're all very useful just in very different use cases and for different users, for different situations. Okay, so this is Pulsar Studio. It's a beta version. So it's available online. Anyone can enter it at pulsarstudio.pasqal.cloud. And it's a visual representation of their technology, an interactive representation of their technology. So the idea here was to go very low level because they really wanted it to be very specific for their particular technology and their research. Yeah, and this is the interface. So what happens here? First of all, we have the register, an arrangement of atoms. And then when we arrange our atoms in certain way, we build sequences of laser pulses that are we send to all of the atoms or specific atoms, and it's all very, very interactive. It's can move everything around. We can generate different patterns. We want it to be very, very intuitive and something that without any knowledge on building the algorithms, people can use as well. We have the code panel here as well, just also to show what's happening. And yeah, and these are the light pulses. We can easily change everything, add pulses, and there is also a simulation. So if it's a smaller number of atoms, there is a simulation, online simulation available. And we can see step by step what is happening here, which laser is being active when. So it's all very, very interactive and intuitive, and at the same time we have different features here, and at the same time we can see what happens in the code. We can also, by highlighting certain elements, we can see how they are described in Pulsar. Most important idea we had in mind when designing this interface was to make it really, really intuitive, because the technology is very complex. And then we wanted the interface to not to add any complexity to this interaction, to leave all the complexity to the actual technology. And I really wanted it to work in a way that even if I don't know how to design a quantum algorithm that makes sense, like what you now see on the screen. Obviously, this doesn't make sense from the quantum perspective, but you can still use the interface. You can still easily play with it. You can still arrange the atoms. You can still make those channels with laser pulses. We really wanted it to be super intuitive. And when Pasqal published the beta version, there was someone who wrote a review, and I have a screenshot here because I really like the way he described it. And he wrote that Pulsar Studio is a fun for the whole family. And the way I understood it is that it's something that can be used by the professionals, by quantum algorithm designer, but at the same time, it's something that this person can give to their kid, and the kid can play and just make, I don't know, a smiley out of the atoms, and just, you know, play around with the light pulses and arrange them in different way, and it's still playful and fun. And for me, it really captures the idea what we really wanted to do with this project. And one way of working, one thing we did in the process of designing the interface to make it very intuitive was to think about what is familiar what would be familiar for the users. And of course, if we're talking about visual graphical interfaces for neutral atom quantum computing, there are no other tools. So it's not like, oh yeah, there are those 20 other tools, and now we can only think about how to make it better. We didn't have a roadmap here. So we're looking at other solutions from different industries and different areas. And for example, for the channels with laser pulses, we looked at all sorts of software for editing music and making music, or mostly editing music or editing sound. And of course, the use case is very, very different, right? Because, you know, here we're editing sound, and here we're designing a quantum algorithm. But in the end of the day, these are some channels with a certain timeline and with those waveforms that the users can move around, can change, can edit. So to make it intuitive, we try to learn as much as possible from those different kind of softwares, but that are so well researched, and there are so many examples of what works best there. And so this was one of the things we tried to do in this project. And also the simulation. So with the smaller setups, it's an automatic simulation up to 6 atoms, and it's possible also to simulate setups up to 12 atoms. And there was, when we were user testing the solution, one of the physicists, one of the people who develop Pasqal's technology, so one of the people who know about it the most, this person told us that I don't even have to think what happens physics-wise. I can just follow what's on the screen. And I really liked it because it was quite obvious for us that this will be good for the business cases. It'll be great for education. But then I was really happy that it was also valuable for their own internal research team. So the people that know the most in the world about Pasqal's technology. And I know that they still use it, and that a lot of the physicists and engineers in the Pasqal's team, they still use it. And this is also like a very, very small example of a very basic example of how it can be useful in this R&D, like for an R&D use case, so a research use case or development use case. And you can see on the left side the register, the six atoms, 6 qubits, and on the left side you see the code. And when we highlight the atoms, we can see where they actually are in the code. And when you look at it, it's quite obvious that, you know, to arrange the atoms in this way, it's very intuitive. It's very simple to do it in this very graphical, visual way. But to do it in code, it's just not the right tool. It's something that's quite obvious. And of course, there are many different ways the researchers use it, but I think this specific one shows in this minimum, like a very small example of how it is useful for the researchers. And of course, you know, from the beginning, when we were developing this solution, this business case was very important for us. So all the business situations, and it's just so much more efficient. It's much easier to showcase the technology when the business people on Pasqal side, but also the client side, when they have something that is interactive, that is visual, that doesn't require, you know, 2 months of studying of how to use something. And so this was from the beginning very, very important point for us, how to make this interface that it's very intuitive. It shows the technology instantly, but at the same it's a real thing. For now, if you go to the website, it's still not connected to Pasqal's QPUs, but the moment they release the QPUs to public, it'll be connected. So anyone will be able to execute an algorithm built in Pulsar Studio on their actual quantum hardware. And now I'll show you another project. And so this is the Quantum Flytrap virtual lab. It's an interactive, also available online, interactive optical table. So kind of a sandbox where users can drag and drop elements and make experiments or recreate experiments. And this project started at CQT in Singapore over 4 years ago. And we went there, we're a group of people, work with physicists and software engineers. And we worked on a game or a computer game about quantum physics. And later we continued the project and it became the Quantum Flytrap projects. And we decided to go more into the direction of an educational tool rather than a game. It's free to use for anyone, and I know that a lot of educators around the world are using it, from high school teachers. There's a number of online courses that use the tool during the courses. But also at universities, for example, the Oxford University, they're using it at the quantum information course. Yeah, so this one is mainly educational. This was always the main idea here, and I'll show now the platform itself. So we have this. This board, this is this virtual optical table where we can drag and drop elements and to start like here, and we can edit all of the elements to create whatever experiment we'd like to see, and there is we have a simulation, so it's it's the same simulation we used for the project for Pasqal, for Pulsar Studio. So it's not only, you know, a playful, colorful visualization, but it's also like all the math is there. So users can see what happens step by step. And we have different features that users can use to learn more about what's happening on the screen, and we have up to 4 entangled photons, and we have a number of saved experiments because again, this is an educational tool, so this is people can look at different famous experiments and see how to recreate them in our lab. Go back to the presentation now. And the idea and the inspiration is quite obvious here, of course. It's a visual, it's an interactive online representation and simulation of optical table. And of course, we looked a lot on how these experiments are represented in the scientific literature. So this is, of course, very, in a way, very similar, which has made it interactive. And maybe also a bit more playful. And the project, as I said at the beginning, the project started as a game and later evolved into this more educational experience. And at a certain point, we're thinking about changing the interface, this graphical layer, to something a bit more serious. But we talked with the users and we found out that actually the majority of people like the fact that it was all colorful and playful, maybe because it's educational, so it's probably students and young people that like games. So we decided to stay with this gamey feeling, gamey look. And one thing I really liked, and I think was very valuable from the beginning with this project, was that we were developing it very closely with our users. So on one hand, because it's free to use for everyone, so there were just a lot of people sending us messages, emails. We have a Discord channel, so talking to us and telling us their ideas and what they would like to see there. Also, what doesn't work, if we had some bugs, that was also very, very useful. But we were also asking other researchers and scientists, physicists to tell us what they would like to see there. What do they think would be great to have? What features, what elements, what kind of experiments they would like to see? And for example, someone told us that it would be great to see the Elster-Weidman bomb test, the thought experiment. So we were like, okay, great. We had a bomb already, so we had to do some changes to be able to add this experiment. But we did it, and then my colleague actually talked with Lev Weidman, and he showed him the experiment. And I don't think he had a lot of feedback. He didn't immediately understand everything that was happening there. So it was obviously very, very important feedback for us. And we tried to incorporate as much of his feedback as possible. But we also asked him about some other things he would like to see there and what could be simulated there. And for example, he mentioned, oh, it would be great to have indistinguishable particles for 2-photon interference, or the GHZ entangled state. So we were like, okay, great, let's do it. And we added these, and this was from the beginning. This was the process. We were asking people, and of course, we weren't incorporating every single feedback, but from the beginning, this process was very, very natural, and we were just trying to listen and like, okay, let's do it. This sounds great. And as I said, of course, the main usage was educational. And a lot of educators used and still use this tool. And we had a really nice situation that I will talk about now with a much older version. It was a few years ago, so it was much older, much simpler version of the lab. It was just the beginning of the pandemic. And a professor from Stanford reached out to us. She found the tool online, and she reached out and she said that she usually has those hands-on experimental classes, but now the pandemic started and everything moved online, and suddenly she was left with a textbook. So she was looking for something a bit more interactive, a bit more fun for the student, and she found our project. And then, of course, she and the students, they gave us a lot of feedback, and this was really great. And we made a lot of changes according to their feedback. And at the end, she told us that even when it becomes possible to teach my class in person again, your website, your project could help me scale to a larger class size than is possible when I require equipment for hands-on demonstrations. And I really liked what she said, because this is, in a way, it's really talks about what I said in the beginning. So of course, this interface, this is not instead of the actual lab, right? But it's a different way to interact with it. And it's a different way to learn about it. So this professor, she would still have this experimental, this hands-on class, but she could use this tool to make a class to a much larger group of students. And for me, this is the main reason to build those visual interfaces, not to exchange a different type of interface, but to open this technology to some new situations, new use cases, and new users. And now I will show a third project, third quantum project. And this is it's just a sneak peek. I can't show the full project yet. It's not released. We're still working on it. So I'll only show a bit of the design. And this is something we're working on with Classiq. Classiq is an Israeli startup based in Tel Aviv. And we're working on this kind of visual graphical interface, graphical user interface for the Classiq platform. And just to give you a bit of context, so this will be part of a much broader product. So it's not it's only a part of Classiq's product, and the Classiq platform allows user to design, to design a model that can be later synthesized into a quantum circuit that is optimized in certain way depending on the use case, depending on the needs. And later users can execute the circuit on any of the available quantum backends, so quantum simulators and actual quantum hardware, all in one platform. And the project I'm showing will be part of this first step, so building the model, building the functional model, the algorithm. And as I showed you on this slide, we're building this kind of node interface. And this again comes to this question about how to make it as intuitive as possible. And how can we learn from other solutions, from different industries, different use cases, but how can we learn from them, from things that are researched really well? There are a lot of different products, and how can we learn from there and build something for quantum? And we decided to use this kind of node interface. And on the one hand, the things we researched and we looked at, so one hand, it will this whole world of electronic circuits, schematics, netlists. It's maybe not the most user-friendly, but there's a lot of important solutions there that are very, very relevant for building quantum algorithms. And of course, more typical node interfaces, for example, for 3D modeling, like Blender, There's some music software. There's a lot of automation software. So there are quite a lot of different solutions that were developed for very different industries, and we're trying to learn from them and see how can we translate it into quantum. And it's we tried. I hope it'll be very simple. So the users will just choose blocks, either functions or gates, or they can create their own blocks and they just wire them together. And they can add more and more blocks and wire them and build the algorithm in this very, very visual way. They can merge them. If they have a lot of small blocks, they can merge them into bigger blocks. They can build their own blocks from scratch. And I think it'll be also really good for adding external data. This is also something that comes back when I'm talking with users, and especially users from different domains. So someone from finance, maybe they would just like to have some kind of finance block where they only upload their CSV or some other format of the data. Be also really great for all sorts of visualizations. That's very natural language here. And of course, it's still not released. So the use cases, it's only something that we think of, and I hope to learn about different use cases when we do release it. But some of the situations where I think it could be useful would be like, for example, for maybe domain experts, like I said about finance and people that they might not, maybe they don't want to work in code so much. It might be easier for them to work with something visual. But also I hope it'll be useful for researchers. So I can imagine the situation that someone is working on the research, they're publishing the research, and then they can have this interactive visualization of the research, interactive representation of the research that anyone can play with, can interact with, and can maybe build upon in a very intuitive way. And of course, for learning, again, all the visual solutions, I think this is something that is really a no-brainer for learning. And I can imagine someone opening an example of an algorithm and then looking inside and seeing what are the different building blocks of this algorithm, and trying to build their own algorithm. So I think this for sure will be really valuable for them. And again, this is just a sneak peek. This is just a design. So, but I hope that it'll be some first version will be available soon. So stay. You can check the platform to see. Hopefully soon it will be released. And the last project I wanted to show you is something very, very different. And it in a way comes back to this idea of different users and different situation and producing very different or researching very different types of interfaces, of ways we can interact with technology. And this is a project I did a few years ago. It was an art installation for a theater play about the human technology interaction, and we built this. I designed this swarm of electronic objects. I designed objects and the electronic part, and those objects were placed around the actors, and were also some kind of an actor in a way, and the interaction was happening. So the kind of the interface was it was a voice interface. So the actors would interact with this installation with their voice, and the installation would reply with voice and with sound and with light, and it would change depending on how the actors interacted with it. And this is, when we think about this, it's a very different use case and a very different user type than physicists, for example. But when we think actors on the stage, and of course, having an interface where they click somewhere on the screen with a mouse, that wouldn't be suitable. That would probably be very boring and just not something they needed. And of course, this is in a way exaggerated, but I wanted to show it that we should really think about interfaces as all the different ways we can interact with technology, and that each different type of interface refers to a different or answers to the needs of a different group of users or a different situation, a use case. For example, physicists or actors. And these are the 4 projects I wanted to show you today. So thank you very much.
Thank you so much for such a great talk. Thank you for sharing with us all your projects. The first thing that when we see all of these projects, and especially interface, we see a lot of purple. And I have a question about this, because also at YQI, some of the work that we're doing, like most of the quantum is becoming purple, like it's shifting towards this color. I was wondering why did you pick this color? Is it because it's more of a dark system, or like did you have a meaning behind it? Like why did you pick this? That'll be my first.
Yeah, that that it's funny because when I put all of them together, I also thought that it's very, very purple. It was something that it was very intentional with Quantum Flytrap, and I really researched at the beginning what are the colors that kind of make people think about quantum things, and I was very happy to find out that it was all this like purple, sometimes like yellow, pink, but I think it's probably a mix of what works well, and what I personally like. It's always somewhere in between. And these are all just like dark background interfaces, which I think this mainly comes from the fact that with each project, this would be always a discussion, and we would think that, okay, with the users we have in mind, usually people tend to choose the dark mode. That's
that's be a debate in the labs. The dark mode.
That there's a lot of definitely, but that's why it's like a first stage. Then ideally there should be the light mode added as well, but also for sure something that I do like a strong color.
It is very
to be used.
Very beautiful, yeah. The reason why we're using purple a lot is because on the Blocksphere you have like the 1 and 0, and then like it's a mix of, usually physicists use red and blue, and so to sort of like hint at the superposition of states, it's nice to have this like purplish thing that comes in. So like it was interesting to see, even if it's not the main thing. Another question that I have, and for people in the audience, if you're at YQI, feel free to unmute the room if you want to talk, or you can use the Q&A feature at the bottom of the screen to ask your questions. One question I have is that, how did you jump from doing installation and education installation to quantum? Like quantum is seen as often scary. Like what was your process, and like how much did you know before going into quantum? To working on this, because I think to create very valuable interface, you need to have a good understanding of what's happening in the technology to be able to recreate and simplify it without oversimplifying it for the audience.
So I started at CQT. This was like literally the first time I started to learn anything about quantum technologies, it started a year earlier. I was participating in this project made run by MIT Media Lab in Berlin. They did this like European short, like 1 week project, and invited all sorts of people from Europe to participate, also about this crossroads of technology and design, music, art. And there was one person there who was a quantum physicist, and then somehow we stayed in touch. And a year later, I saw that he's looking for people to come with him to build a game about quantum physics at CQT. And I thought, oh, that's perfect. What could go wrong? So it literally started like this. This wasn't intentional, and I thought it'll be a fun, weird project I'll have in my CV. And then I started working on this, and I started working with a lot of physicists. And I thought, wow, this is the most interesting and the most amazing thing you can imagine. And I thought, okay, that's what I want to do. I want to stay in this industry. But of course, all of these projects, these aren't only my projects. There was always a team of developers and physicists. So it's I wouldn't be able even to do the design. It's a collaboration of the whole team, and it's everyone's ideas. So there was a lot of physicists involved here. And with the time, I of course know more and more, but I'm still not a physicist.
Yeah, but I think that's the beauty of working at the interface of science and technology and art and humanities, that like you really need to bring people from multiple skills, because while a physicist can be really good at explaining the technology itself or building the technology, they might not be necessarily good at doing interface and like helping convey ideas on the graphical level. So like I think that's really a brilliant move on all of this interface. You also talked about the fact that you are using software technique that people are used to. For example, like the same way that we have still the little save icon being a floppy disk in the corner of your screen, while we don't use floppy disks anymore. It's interesting that you're going back to how we make music, how we make like Blender nodes and things. Like, can you talk a little bit more about why are we always using for interface stuff that reminds us of the past, for like the objects outside of the virtual, similar to how the notepad on software used to be a physical notepad and they tend to be yellow, the same way that the paper used to be like that kind of thing. What's the reason behind it, and how can you use that to your advantage for the design of interface for people who don't know necessarily the technology?
So I think, first of all, it doesn't need to be like this. And I think there are many cases when we want to, when you think about something, for example, very simple, maybe some kind of a website, when, designers try to be sometimes, go crazy with the interface. And the whole idea is about doing something very unusual, very different. So it really depends on the use case. It doesn't need to be like this. But in the case of quantum, I think the technology itself is so complex that I always think that I don't want to add to this complexity by an interface that is hard to understand. And that's why I try to design interfaces that are intuitive, that they're very, users immediately know what to do, or it's if they need to learn a bit, it's very little, and to leave this time of learning to learn about the technology and not the interface itself. And then, of course, we all use interfaces all the time. So by using the interfaces, we'll learn about how this world works. So then using certain solutions from other industries, from other totally different areas, it's something we know. It's just something we've learned already. So it's very intuitive for the users to use the same to behave in the same way when they see this interface, even though it's quantum and not music. But we see this channel, so it'll be very intuitive to know, oh, okay, I can probably swap, or I can do this or that.
And when you're play testing this application or like education content, do you because here on the call right now we have a lot of people who have shared like mixed experience. Some have not at all understanding of quantum, some have some work in quantum physics. And so when you've tested with all these people, is there when you have somebody who doesn't know anything about quantum physics playing on this platform, how does it impact the fact, like the interface and your work, then if you have that person on the platform and also a very qualified person who knows a lot, like how do you work to make sure that the platform is available for both type of users? Because I think it's a bit of a challenge to have something that is robust, complex, but still making it available for people who don't know anything. Like if they want to, you've been writing 2023, I think that was for your New Year's Eve celebration. I've seen online a couple of like Christmas tree and stuff like this, like really fun interface. But like, so to engage the audience that doesn't know much about quantum, but like, how do you convey these two type, like how do you create interface for these two type of users?
Mm-hmm. So I think there's this one idea that I really like, that I think it was Professor Mitch Resnick who built. There's this software for children to Scratch to learn programming, this like visual way of how children can program their own games or all sorts of things. And he wrote a book about building software, and there's this really nice idea there that I think a lot about when I'm designing the interfaces. It's about making low floors, high ceilings, and wide walls. So it should be very easy to start, but at the same time, it should give users a lot of space to continue beyond this, like very basic examples, very basic things to make. So for example, we have the simulation in the lab, right? So if I'm not a physicist, I won't use it because like I don't really understand it, or maybe I can use it and learn this way, but it's there. And for the more advanced users, it gives them this additional way to use it. And also ideally to make those wide walls, so to give possibility for users to go with this into different directions, to make their own things. So it's not only to recreate what we did, but also to learn from them, like we did with Quantum Flytrap. That it was like I said about the development, that we would always listen to the users and add new features or new elements when they were telling us that I have this interesting use case in mind. So but I also have a kid she's 7 now, and so I always show her what I work on, and she's also testing. So the Pulsar Studio was yes. So like okay, if she can arrange the atoms, that's good.
That's a good thing, yeah. Also, I like the fact that you also work with theater. I have a theater background, so I used to be an actor when I was younger and switched to science later on. Is there a way, like I've always wanted to bring theater into quantum? I know it's going to be very difficult, but is there a way, like can you imagine a way of bringing that type of arts into the work of quantum? Which could be, like, I think really challenging because we're talking about very different things, but like, since you're mixing technology and theater here, like could we imagine a pulsar integration, for example, onto a play or something like this? What could be your, like, it's not even a question, but it's tough. Like that's really a domain that I would be interested in going into.
Yeah, I mean, I would love to see something like this or work on something like this. I definitely really love the projects that go out of this realm of only things that happen on the screen, or like at least this user layer is on the screen. So I definitely really like all sorts of installations and building and designing those experiences in space. So I think there's definitely a lot of space here for some experimentation. And it reminds me of when I was in Singapore. It was the beginning of my of me working with the quantum industry. And of course, as I said, I didn't really know anything or too much about physics then, like probably, you know, school level that I also forgot a bit by then. And I remember that a colleague, she's a quantum physicist, she was explaining at certain point, it was something about light waves and she was showing different kind of waves with her, like she did like this whole dance and she was moving like she was pretending to be the wave. So probably there, you know, there is a lot of space for thinking about something creative here.
Fascinating. Well, thank you so much for taking the time to talking to us about all these projects. It has been really a treat. For people, there was like the URL on every project, so I will invite you to go online and test all of this interface. We'll keep an eye on the Classiq interface to soon be able to play with it. Thank you very much for your time, and we hope to see you at another YQI non-technical talk event soon.
Thank you so much. Thank you for inviting me.
My pleasure.